Hello everyone, thank you for watching my video on how I have built this unregulated power supply kit from Tamagawa. It is a heavy-duty multiple converter full bridge type full wave. Bridge type full wave. You can see here the schematic that I followed. Let's start from the very left. First of all, this is the transformer that we are using. It is a transformer that has a 220 volt input and an output of 3 volts, 4.5 volts, 6, 9, and 12 volts with a rating of 750 milliamps up to 1 amp. So the purpose of this project was to create a power supply that can supply us with a DC voltage. So the current. As for the demonstration, we can use this. Let's say that this is the AC voltage that we are seeing from our outlets in our homes. It is sort of like this, alternating towards the positive and negative, and it hits zero on this line. So our aim is to convert this signal into this signal like this. This is what a direct current voltage looks like on a graph. It is straight. It does not have any dips or it does not have any highs. The first thing that we could do in converting the AC current here is by using these diodes. 4 of these diodes in a configuration that makes the alternating current go in one way only. So let's say in this circuit we use this setup right here. The stripes on these show the negative side, and this is the positive side. This is both positive, this is both negative, and these are the outputs. The black one is the negative output and the red one is the positive output. So this is the diodes in that formation. The line represents the stripe that I showed earlier. So this will be the positive output, then this will be the negative output. You can see that I configured the capacitor like this because I did not have a PCB to put it on. So I just connected directly to the leads here. So you can say that the connection here is just like this. So we will have the capacitor here, and then on the next side we have the soldered resistor that can be seen here. Then these are the outputs now. So yeah, the resistor, by the way, is a 1 kilo ohm resistor, and then the capacitor is 25 volt and 1000 microfarads in capacitance. So this is the positive, then this is the negative side. So that's basically it. All right, this is connected to the common ground, or zero or common. Yeah, and that can be found in the one of the outputs of the transformer. Then this is where the switch comes in. The switch is basically the potentiometer This is where we select either we use 0 or off, or we can use 3, we can use 4.5, and so on. And that goes up to 12 volts here. That is how you change the output voltage using the potentiometer. The leads here are connected, of course, to the output of the transformer. Then the middle part of the potentiometer is connected to this side. This is the connecting. This is the connecting wire that finishes the connection. So when you put it to 0, it turns it off. There will be no output. So that's basically how it goes. On to testing. So we will have our cord. We will plug it in. Make sure both of the outputs are not touching each other. So here's the negative, and we will connect it. So this power supply is now live. We can see, we can use a multimeter so that we can see the voltage. Oh, remember to not operate on, do not touch any of the wires because you may get shocked, especially the input line is very dangerous. So we will clip the probes. Positive probe on the positive output, then the negative probe on the negative output. And so we can turn it on now. Let me focus on the. So now we will put it to the range of 10 on the multimeter. This is just a cheap multimeter, so the rating might not be accurate. Then we will look at this part. Like, you can see this part here is the 2, 0, 2, 4, 6, 8, 10. That is basically where the range of 10 can be seen. So right now, judging from the lines, we have 3 volts of DC output. Then we will, when we turn it up back more, we will get 4.6 because the output is not really accurate, or there's still a margin of error on the output. I have a problem with the system. I do not know why. I think it's the capacitor. But when I put it to 6, the output voltage is at 7.5. I really don't know the reason why it's like that. Then I will now put the range to 50 because the 9 volt goes up to 12 volts, as you can see. Now we will look at this 0, 10, 20, 30, 40, and 50. So now the output is 12.5 volts. And then lastly, we have 12 volts, which outputs 16 volts. I honestly don't know why, but that's 16, or yes, it is 16 volts. So that's basically it. You can control the output using the potentiometer. We can turn it off like so. Now that's back down to 12 again, down to 7.5, 4.5, 3, and then off. So yes, that's the presentation. Oh, I might add that in order to prevent the leads from touching the metal casing, I MacGyvered some cup coasters so that it can be used to insulate it from touching the walls, such as this. There's one here, there's one here. I put electrical tape on the transformer so that it would not, it would not touch the leads. And then the potentiometer is also taped so there won't be any short circuits. So that's basically it. We can close this up by doing this. And it's closed. Now you just have to screw everything back in. Thank you for watching, and that's my presentation.